Hi all, it's good to see you here again. Welcome aboard this live video. I hope everybody is doing well. I'm Steve Letier and this is my first live video, so you might expect some mishaps. Please excuse me in advance. I hope everything goes well, but you never know, especially since English is also not my day-to-day language. Why am I doing this? Today's topic will be a discussion about SN16 potential hypersonic flight test. If you have any questions, feel free to ask me in the chat. No need to pay any subscription for that. It's completely free. But first, I wanted to go back to what happened today. Today has been an interesting day with 2 launches and 95 satellites sent to orbit. I'm sure that's a new record. Can anyone confirm? First, we had Virgin Orbit's Tubular Bell Part 1 mission with the Cosmic Gold 7747 taking off from the Mojave Desert. They sent 7 satellites to a polar orbit for 3 customers. I don't know about you, but I like this rocket. I like the air launch concept, even if it's probably not really worth it. And I like the rocket even more. The way Virgin Orbit uses the exhaust pipes as a way to control the wall is really neat, if you ask me. Welcome to this live. If you have any questions regarding SN16 hypersonic flight or anything else, don't hesitate to ask in the chat. I'll try my best to answer any questions. Anyways, the other launch of course, today was SpaceX's Transporter 2, the second launch of the rideshare program. It was rescheduled from yesterday because there was an aircraft in the perimeter. I won't comment on Elon Musk's rant about what he calls an unreasonably gigantic keep-out zone, but feel free to share your thoughts in the comments if you want. And oh boy, this was a huge rideshare. 88 spacecraft sent to orbit in a single launch. The best part is SpaceX is 5 times cheaper per kilogram in orbit than Virgin Orbit and Rocket Lab. Yes, 5 times cheaper. Some so-called analysts say SpaceX is killing the game and will leave nothing for its competitors. If you want to know why this couldn't be further from the truth and why both SpaceX and Rocket Lab and Virgin Orbit and probably some other ones will all launch those nanosats and microsats in the future, you should definitely check my last video. I explain why in a constellation, and especially small ones with half a dozen satellites or so, you don't want to launch all your satellites on the same rocket. And if you have to wait 6 months between 2 rideshare launches, your constellation can take years to complete. Anyways, check this out in the links just below in the description. Anyways, that's enough for the news of the day. Time to dive into SN16's hypersonic flight. Let's do a quick recap to be sure we are talking about the same thing. SN16 was being built alongside SN15 to perform a low altitude and landing test in case SN15 had failed. As you all know, SN15 was a total success, and SN16 to SN19 prototypes were all cancelled to focus on the construction of SN20, the first prototype to try an orbital test flight. SN17, 18 and 19, the construction was stopped and the parts was scrapped or reused, but SN16 was already finished, as you can see, and ready to fly. At first, SpaceX decided to recycle the whole ship and move on to the orbital test. But someone in the team probably had an awesome idea and convinced Elon there was something to do with the finished Starship prototype. And SN16 was the center of the attention again, with technicians working to adapt the ship to its new purpose. As always, Elon spilled the beans and revealed what the idea was through his tweet. Here it is. We might use SN16 on a hypersonic flight test. And to be fair, that's pretty much everything we know for sure about the whole thing. So be warned that what we are talking about today is highly speculative. And things will probably happen differently if they happen at all. But I think it's way more fun to try to make educated guesses instead of just waiting for the thing to be revealed. So fair warning, even though I try to find facts to support my claims, do not take what I'm about to say now for granted. And don't hesitate to tell me if you agree or not with me. And of course, ask any questions if you want. So why a hypersonic test? So let's start with the definition. What is hypersonic flight test? That one is easy. Hypersonic means your craft moves between Mach 5 and Mach 25. Mach means your speed is compared to the local speed of sound. Mach 5 means 5 times the speed of sound. The speed in question is supposed to be relative to the air, meaning you have to take the wind into account. But at those speeds, it's pretty much negligible. What I sometimes see is people converting the Mach numbers into regular speed in meters per second or miles per hour, using the speed of sound at sea level. But that's not the correct way to do it. Here is a chart showing you the variation of the speed of sound with altitude. The speed of the sound changes with air density, which is a function of altitude and temperature. But for rocket flight, you can consider the temperature as a function of altitude. So I will simplify this and say the speed of sound depends on the altitude. As you can see, past the first kilometers or miles, the speed of sound varies a lot, with several turning points in the graph. In the whole atmosphere, Mach 1 can be anywhere between 270 and 340 meters per second. Multiply that gap by about 5 or 25, and the actual speed change can vary a lot. But in day-to-day rocket speech, hypersonic mainly means reentry, when the spacecraft is coming back from space and breaking into the high atmosphere in a ball of fire. The Starship will follow a re-entry trajectory close to that of the Shuttle. Here you have the typical Shuttle re-entry profile, with the altitude in blue and the speed in red. Official entry in the atmosphere is at 130, but you can see the braking starts with a turn in the curve just before peak heating, around 75 kilometers in altitude. Here I highlighted the radio blackout zone, where serious braking occurs. Everything happens between 55 and 75 kilometers, with speeds between 3.5 and 7.5 kilometers per second. I think this is the flight envelope SpaceX is willing to test with SN16. Of course, one of the main goals of such a flight will be to assess the heating stress endured by Starship and answer those questions. Will the thermal protection tiles be up to the task? How will the ailerons and hinges be protected? And of course, SpaceX wants to check if the Starship is flying well at those high speeds. In this tweet from 2019, Musk responds to Tim Dodd, the everyday astronaut. He explains the Starship will behave just like the Space Shuttle and generate lift to remain at high altitudes for a longer time. This will reduce the peak of heating, and that's crucial to avoid melting the whole ship upon re-entry. The Space Shuttle had wings to do that, and the Space Shuttle had wings to do that, and that was a really strong effect that helps reduce the heat. In this tweet from last November, Musk explains how Starship will fly. During the low altitude flight tests, Starship had an angle of attack of 90 degrees. It was going belly first. An angle of attack of 70 degrees would mean pitching forward part of the ship towards the ground by 20 degrees. If SN15 had done that while going down, the whole craft would have started to move forward. Now imagine the same thing at very high speed, but this time the Starship is not going down but horizontal. If you pitch the nose forward, then the airflow will make the whole ship go up, or at least it will not go down as fast as it would have. You don't need wings to generate lift. Since Gemini, the capsules, including Soyuz, Crew Dragon or Starliner, use this trick to generate a little lift and reduce the heating and G-forces experienced during re-entry. Of course, with its wings, the Space Shuttle was better at this. Starship should behave closer to the Shuttle than the capsules. If you ask yourself, why bother doing this test, the orbital test will cover it anyway. Yes, it might, but the orbital flight test will most likely not be a success and no data about the re-entry may be recovered, either because the failure happened before re-entry or because the failure was so bad that the data was lost. I made a video about all the things that can go wrong during the orbital flight. The link is in the description. Now it's time to look at how this flight could take place. Musk already said the Starship alone is almost capable of reaching orbit on its own. In this tweet from 2019, he says without a heat shield, landing propellant and payload, Starship could technically be an SSTO. For hypersonic flight, the heat shield is mandatory. Landing propellant will help balance the center of gravity, so it is mandatory too. But SN16 doesn't really need to go to orbit. Going a little slower is perfectly fine to test re-entry. That's why the hypersonic flight will probably be just SN16 flying on its own on a suborbital flight. But not suborbital as New Shepard, which is just up and down. SN16 will have to accelerate a lot sideways to generate enough velocity. The craft will then crash land in the ocean, just as SN20 intends to do. I've tried to assess how far SN16 could go. I didn't do fancy math, so this is just to have a rough estimate. Excuse me. These charts from flightclub.io. This website by Declan Murphy does an awesome job of providing us with a bunch of telemetry data from a lot of flights. I've looked at a launch by the Falcon 9, and orbit is reached at roughly 1100 kilometers, which is 700 miles. This is downrange of the launch pad and at an altitude of 2000 kilometers or 124 miles. Therefore, a Starship following roughly the same flight profile could have its apogee probably lower to save fuel and then come back following the same curvature, which could mean an impact in the ocean 2200 kilometers or 1400 miles downrange. And that spot would be somewhere north or south of Cuba, depending on the trajectory. Of course, that's just a very rough estimate, but SN16 will probably not end up near Africa with a hypersonic flight. The Gulf of Mexico, or a little farther, will probably be the endpoint of its trajectory. And that would be it. Tell me what you think about it in the chat. Of course, if SN20 flies before and is a full success, there is no point in flying SN16. But who knows, maybe there will be some issues with Super Heavy or its Raptors, and the next best thing to do will be to fly SN16. Thank you all for being here today, that means a lot to me. If you liked what you heard, that would mean a lot to me if you could leave a like. And don't forget to subscribe, I have a lot of videos to come. I think I will end this live now. Thanks again for watching. This is Getting to Space, signing off.